Hi, in today's lesson, we're going to learn about domain and range. So the very first section has some fill in the blank. So you're going to want to pause the video to fill this information in. It says in our last class, and this is not strictly our last class, and probably a couple lessons back, we talked about functions and we used 4 different representations. We talked about graphs, tables, situations, and mapping diagrams. Remember that you can identify a function by observing the input. Those are the x values. If they repeat, then the relation is not a function. And you must use the vertical line test when determining if a graph represents a function. So first thing we're going to talk about, let's suppose we're going to talk about birthdays. So the directions say to create a table of values to show birthday months of students in our class, and I've just kind of already done that. So I've made the table with the birth month and the number of students whose birthdays fall within that month. So you're going to want to copy that information down. So the domain of this, and I want you to go ahead, I'm going to put X up above month and Y up above number of students. So the domain is going to be the following values. And so you're going to do that little squiggly bracket, 1, 4, 6, 7, 8, and 12, and then do the squiggly bracket again. And the range. Now, when you've learned about range before in earlier grade levels, you talked about the biggest number minus the smallest number in a data set. This is a different type of range, okay? So our range here is going to be 1, 2, 3, 5, 8, and 9. So how did I come up with the domain and the range? Well, let's talk about that. The domain of a function is simply the x values or the input. So is the input values or x values. The range is all the y values or all of the output values. And that's really it. Okay, so there are different scenarios where you're going to have to find the domain and range. So the first is a set of ordered pairs. So first, when I do the domain, I'm going to do that little squiggle, and I'm going to go through and highlight all of the x coordinates. So those x coordinates are the domain. So 2, -1, 2, and 0. Now notice I have 2 written down twice. I don't need it written down twice. I'm only going to need to write it one time. And then my squiggle. Okay, so those are all the possible domain values. Now let's talk about our range. Remember that the range is the y values, which I've just highlighted in green. So that's going to be 3, 0, -5, and -3. That's my range. That's it. Okay, let's go to the next one. So in part B, we have a table of values. So the domain, let me highlight it this way. This is the domain. That is the range, okay? So for my domain, I'm going to list 3, -3, 7, -8, and 0. And then for my range, I'm going to list 7. Notice there are 2 7s. I'm only going to write it down once. 7, -2, -5, and -1. And that's it. In part C, this time we have a mapping diagram. So the domain is going to be all of my inputs. And then the range is going to be all of my outputs. Okay? So for the domain, that's going to be 0, 5, and 10. Oops, give me just a minute. And then for my range, that's going to be 2, 3, 4, and 5. Okay? And then what if you have a graph? Okay, so this one is a little bit different with the domain and range. So in this graph, I have ordered pairs. So let's write down the ordered pairs for each point first. Now be careful because it looks like right here, see how there's a 2 here and a 2 here? So they didn't include all the numbers, but it does look like this would be a 1, 2, 3, 4, 5. And this is a 1, 2, 3, 4, 5. So we are counting by ones. So since it's just a set of ordered pairs, I'm actually going to write down the ordered pairs next to the points, okay? So this would be -1, 2, 3, -1, 4. That's 1, 2. This one is 3, -1. And this one is 3, 1, 2, 3, -3. Okay, so now when I go and do my domain, I can just look at the x values. And my range, I can look at my y values. Okay. So my domain, I have -1, 1, and then I have 2 3s, but I don't need to write them both down. You only need to write it one time. And then my range is going to be 4, 2, -1, and -3. And that's it for this one. Let's go to the next page. Okay, this time we're going to evaluate a function. So looking up here, it says determine the domain and range of the given function. So we see that, let me zoom out so you can see that y. So we see we have the function f of x is equal to 3x plus 2. That f of x, just think of it as a y. So I'm going to substitute a 0, and we'll start off by substituting a 0 in for x. So I end up with 3 times 0 plus 2, which is 0 plus 2, which is just 2, right? So I'm going to put a 2 over there. And then I've got to substitute in a 2, so I'm going to do 3 times 2 plus 2. So that would be 6 plus 2, which is 8. And then I'm going to substitute in a 4, so 3 times 4 plus 2, which would be 12 plus 2, or 14. So the domain, if the domain is 0, 2, and 4, then the corresponding range would be 2, 8, and 14. Okay, I want you to try this application problem. So I want you to try that, pause the video and try this application problem, and then come back and we'll check. Okay, so hopefully you got this application problem correct. In case you were wondering what withdrawal means, remember it means you're taking out that amount of money. So make sure you've paused the video and get this information written down. Make the necessary corrections on your sheet. All right, so let's go to the next page. On the next page, we're going to start talking about continuous and discrete functions. So you're going to want to pause the video to get these definitions written down. A continuous function is a function whose graph is a single unbroken line or curve. In other words, you could draw this function without lifting your pencil from the paper. Now, a discrete function is the exact opposite of a continuous function. It's a function whose graph is a series of unconnected points or lines. Okay, or in other words, if you were to draw a discrete function, you would have to lift your pencil off of the paper to continue graphing it. Okay, so if you'll look at these two examples, we can see that the first example would be considered continuous. So we're going to write continuous. And the second one would be considered discrete, because those are unconnected points. All right, so let's do a few examples here. All right, so this first one, the graph is it discrete or continuous? So this one, we would consider it continuous. Remember, if I was going to draw that, I could draw it in one swoop, if you would. So we would say this is continuous. And then let's talk about our domain and range. So again, when we talk about domain, I'm going to highlight the word domain. When I talk about domain, I am talking about the x values. So I'm going to look on the x-axis, and I'm going to highlight on the x-axis starting here all the way to here. And how did I know to stop there? Because right here is where the first x value is, and right here is where the last x value is, because I have those two end points. I also want to point out that these are shaded circles. Remember when we were talking about inequalities and we said the shaded circle means it can be that point or that we're equal to that point? So that's going to come back into play here, all right? So our domain is going to be any value, because it's continuous, any value between right here and right here. So any value between -1 and +3. So I'm going to write this in this type of, I'm going to write it in two forms, okay? So first I'm going to write it in what's called interval notation. So interval notation looks kind of like an ordered pair, okay? But it's not an ordered pair. So you're going to either have parentheses or you're going to have brackets around those points. So there's parentheses, or I could have brackets like this around those two numbers, or a combination of the two. So how do I know which? Well, first, is -1 a possible domain? Yes, and I know it is because of this point right here, okay? It's shaded. So that means I'm going to have the bracket. Then I'm going to say, is +3 part of the domain, or is it got that open circle? Well, right here I have the shaded circle at when x is +3. So I'm going to have a bracket here. If these two were open circles, then I would have had parentheses here instead of the brackets. Okay, now I'm going to do the same thing for the range. And so I'm going to look at my y-axis and highlight where the possible y values are. So this is the top, and it goes all the way to here at the bottom right there. Okay, so when I look at that, what's the smallest y value that I have? Well, the smallest y value that I have is right here at -4. So I'm going to put -4, comma, and what's the largest y value that I have? Well, the largest y value that I have is right here, okay, with this point, which is at +5. Now I need to know, do I need the brackets or do I need parentheses here? So for this one, can I equal -4? Yes, so then I need a bracket at the -4. And then for this one, can I equal +5? Yes, so I'm going to need the bracket around +5. So that is interval notation, okay? Then there's another way I can write it with the inequality, and that one you may like better. So if I'm looking at the domain is any number between 1 and 3. So I can, or between -1 and 3. So I can write this like that. And x is the variable that we use for domain. For the y's, for the range, the y's I can write like this. Okay. And I know I'm doing the or equal to part because I have the brackets. Okay. That's what that or equal to part means. Anytime you're writing this or equal to part, then you have a bracket. All right, let's turn to look at another example. Let's look at this next one. So first, is this graph discrete or is it continuous? Okay, so this is also a continuous graph. And then let's talk about our domain and range for this. So I'm going to highlight the domain in yellow. So I'm looking at all the x values. So it starts here. And notice that that blue line has that arrow, which means it keeps on going. So I'm going to make my yellow line like that. So how does this look then in that interval notation? So I'm going to start off at 1, and I'm going to keep going forever. So the number that represents forever is infinity. So I'm going to make my infinity symbol. All right, now is 1 an actual part of the domain? Like, do I have an actual point there? Yes. So I'm going to have the bracket. And then around infinity, anytime you're dealing with infinity, you always have a parentheses around there. So that's how the domain would look in interval notation. If I'm going to write it using that inequality symbol, we're saying x can be any number greater than 1 or equal to 1. So I could just write this, x greater than or equal to 1. Okay? Let's talk about our range next. So I'm going to highlight the range using green. So the bottom of the range is going to be right here, right? And then it looks like it's going to keep going, and I think it's going to keep increasing, right? And on and on and on and on, because if this keeps going, it's going to end up moving up and up and up and up and up, okay? So my range, the smallest value I have is 0, and then this is going to keep on going forever, so into infinity. Is 0 an actual point? Yes, so I'm going to have the bracket. And then, like I said a minute ago, anytime you're dealing with infinity, you're going to have the parentheses around that. Okay, so how do I write this using that inequality symbol? So we're saying the range, or the y values, can be any value greater than or equal to 0. Okay, let's do one more. All right, so this time, this graph is not continuous. This graph is discrete. It's a set of ordered pairs. So what about our domain and our range? Remember, domain is a set of x values, range is a set of y values. So for this one, it's probably going to be easier to note what the ordered pairs are, and then we can just pull off the x and the y values. So for example, this point looks to be at -6, -3. This one is at -3, -2. I have one right here, which is at 0, -1. This is at 3, 0, 6, 1. Okay? So when I do the domain, and since it's a discrete function, when I do the domain, I am going to use the little curly brackets and just list out the x values. So -6, -3, 0, 3, and +6. And then I'm going to do the same thing for my range, which is going to be my y values here. And I'm going to do the curly brackets there also. Okay, there it is. So my range is going to be -3, -2, -1, 0, and 1. Okay, so now I'm going to give you an opportunity. So I want you to complete, they're not numbered, so you're going to complete this problem, this one, and that's it. All right, so you're going to complete this worksheet, complete the last 3 problems, and then come back and we'll check. Okay, so let's check over your answers to these last 3 problems that you just did. So here is the first one. And then let's talk about this one really quick. I just want to point out that there was an open circle right here, which means that this is not a point. This is like the barrier point. So when you wrote in your domain, the domain does go from -5 to 4. However, -5 is not a possible value. So you should have had the parentheses with the -5. And then when you wrote the range goes from -2 to 3, but again, that -2 is not a possible value. I also want you to see how I just have the less than symbols here, not the or equal to part, okay? And then this last problem you should have noticed was a repeat of a previous one we've done. If you need to go back, rewind, and get this down, then please do so. If you have questions about any of these problems or anything else in this particular lesson, make sure you bring them to your teacher. Once you've submitted this, you'll be ready for your independent practice. Good luck.